Lesson 407, Inscribed Angles and Arcs, Part 2. The objectives in this lesson: you're going to use the inscribed angle theorem and its corollaries to find measures of inscribed angles and intercepted arcs, and you will use properties of inscribed quadrilaterals. The right angle corollary says that an angle that is inscribed in a semicircle is a right angle. Let's use the corollary just discussed to find the value of x in each example. Assume segment B is a diameter of circle C. So if I want to find x, what I just learned is that if an angle is inscribed in a semicircle, which this one is, ABD, see how its endpoints are on the diameter? Let me get my pen so I can point this out better. Okay, so my end circles are right here on the diameter, and I have my vertex on the circle, so that angle's inscribed within the semicircle, and whenever that happens, that means I'm going to have a right angle. Therefore, x is going to equal 90 degrees. So now let's find out what x is here. Again, I have an angle that's inscribed in a semicircle, so I know that's 90 degrees. And look here, I know the measure of angle A right there is going to be half the measure of its intercepted arc. And right here, if I was to extend these, you can see that here is the intercepted arc, and it equals 100 degrees. And I know that the measure of angle A is going to be half of 100, and half of 100 is going to be 50 degrees. Now let's see that worked out. We say the measure of angle DAB equals half the measure, I hope I don't run out of room here, of arc DB. So I'm going to let this be x, and I've got my half, 100, and then you know, most of us know that half of 100 is 50. That's some pretty easy math there. But if I want to get that 2 out of the denominator, I'm going to multiply both sides by 2. See how it reduces to 1? So I'm going to have 2x equals 100. Divide both sides by 2. X is going to equal 50. That's just to show you how you can work it out if you got values that aren't as easy with the easy math. Okay, now we've got the inscribed angles corollary, and it says that two inscribed angles that intercept the same arc have the same measure. So if you look here, oh, I got me some little animations going here. I forgot about this. It says, by the inscribed angle theorem, the measure of angle ADB is equal to 1/2 the measure of arc AB. Oh, no, I guess my animations are on another slide. I thought they were on this one. So, going on with this one, you see that these angles are congruent and that they intercept the same arc that I've highlighted in blue there and just drawn over with red. Since both of those angles intercept that same arc AB, they're going to have congruent measures. So say arc AB is, let's say, 60 degrees. And those angles are half of 60, so this one's going to be 30. This angle down here is going to be 30 degrees. So you can see how that works out, that they're going to be congruent. Okay, now let's look here. We're wanting to figure out what x is, or calculate what x is. We can figure it all day long because we're Texans, okay? You know, there are so many different ways that you could go about this. But I'm going to go with this. I know that these vertical angles, not inscribed yet, those are going to be congruent. They're both going to be 84. Well, look right here. I know that these inscribed angles are intercepting the same arc. Okay, let's look right here. Maybe this is the one that I have my animations on. Maybe not. Oh, there we go. Okay, so you see that angle ADB is intercepting arc AB. Then you can see that AEB is intercepting arc AB. All right, so they're intercepting the same arc. Well, look right here. We know that this inscribed angle right here is 49 degrees. I also know that if I multiply that by 2, I'm going to find out what the measure of arc AB is. So 49 times 2 is going to give me 98. So I know the measure of arc AB is 98 degrees. And guess what? Inscribed angle AEB also intercepts arc AB. So I know that the measure of that angle is also 49 degrees. Now, if I want to find out what x is, I can use the triangle sum theorem and I can calculate what x is going to be. So I know that triangle ECB, the sum of angles in triangle ECB equals 180. That's what the triangle sum theorem is going to tell me. Okay, so if I take 180 minus 49 minus 84, I'm going to get 47. So x is going to equal 47 degrees. And guess what? Since these triangles are similar, obviously they're different sizes, but we know they're similar and we know their angles are all going to measure the same thing. So that angle right there is also 47 degrees, as well as they both intercept arc ED. So there's another reason I know it's going to be 47 degrees. All right, here's the corollaries that we've learned today. Let me get my little arrow. It says corollary 9.1, we learned that if an arc intercepted by an inscribed angle is a semicircle, then the inscribed angle is a right angle. Okay, the converse of that says if an inscribed angle is a right angle, then the arc intercepted by the angle is a semicircle. So, and I'll remember what a converse is. We just flipped the hypotheses and the conclusion. That's all we did. Okay, now then, we know that corollary 9.1 is true, and if we look at the converse of the corollary, we're pretty certain that one's true as well. It says if an inscribed angle is a right angle, then the arc intercepted by the angle is a semicircle. And that's going to work every time. I promise you, it's true. Now, corollary 9.2 says if inscribed angles intercept the same arc, then they have the same measure. So if they intercept the same arc, they have the same measure. Now, the converse says if inscribed angles have the same measure, then the inscribed angles intercept the same arc. So the question here is that one true? Because you think about it. Can we have two separate inscribed angles with the same measure that intercept different arcs? Well, thankfully, I came up with a counterexample. There you go. There you have two inscribed angles that have measures of 30 degrees. But look, they intercept different arcs. Because, let me see, angle ADB intercepts arc AB, while angle EFG intercepts arc EG. So this counterexample shows that it's possible for two inscribed angles to have the same measure but not intercept the same arc. So the converse of the second corollary is going to be false. The corollary is true, but its converse is false. Okay, let's work through some examples. This says, given circle C with a diameter AB, find the degree measure of the arc represented by X. Okay, what you have here, they told us that AB is the diameter. Let me get my pen. They told us that AB is the diameter. And we know that when we have an angle that's inscribed within a semicircle, that it's going to be a right angle. So if I want to find the measure of x, remember that let's look here, the measure, I don't have another point there, so I'm going to come in and I'm going to add point E. So I know that the measure of angle ADB is going to equal half the measure of the arc AEB. Remember, I named major arcs with 3 letters. So I know the measure of arc ADB is 90. And I'm going to put X there since that's what they call it. And if I multiply both sides by 2, or you can cross multiply here, either way, makes you a happy camper, you do it. Ta-da! I'm going to get 180 equals X. And that makes sense because a semicircle is going to measure 180 degrees. Alrighty. It says, given circle C, find the angle measure represented by X. So here's my circle C. I know that this angle over here is 26 degrees. I know this angle right here is going to be 90 degrees. And let's look. Angle EEB. Let's do this. I'm looking right here, right quick, making sure I got all my ducks in a row. All right, so by the triangle sum theorem, I know that here I've got this 90-degree angle. This angle over here, BDA, is going to be 26 degrees. So using the triangle sum theorem, 80 minus 90 is going to give me 90. Then I subtract 26 from 90. I believe I'm going to get 64. So I know that this degree measure right here is 64 degrees. Now I want you to look that angle, let's say, angle EAD intercepts arc ED. And then if you look, angle EBD also intercepts arc ED. Forgot to put my E in there. Okay, so that means that the measure of angle EBD is going to be equal to the measure of angle EAD because they intercept the same arc. That's what we learned with that corollary about 2 inscribed angles. If they intercept the same arc, they're going to be congruent angles. So that means that X is going to equal 64 degrees. There, that took a lot more explaining. The problem's easier than it was to explain. Okay, let's look at this one about quadrilaterals. It says arcs ABD and BDE are semicircles of circle C. Explain why quadrilateral ABDE must be a rectangle. Okay, so let's look at what they told us. They said arcs ABD and BDE are semicircles. So let's look here. ABD is right here. Everything above that red line is a semicircle. And they said BDE is also a semicircle. All right. Now then, look here. If I have an angle inscribed within a semicircle, it's going to be a right angle. So there's a right angle. Okay, because it's inscribed within a semicircle. This is a semicircle down here. So it's a right angle. Got another semicircle. Angles inscribed within semicircles there. So those are right angles. Oh my gosh, it is a baseball diamond. But we can't assume that it's a square. Okay, but we do know it's a rectangle. So let me try to write this out for you to explain it, because sometimes they ask you to explain means you got to write stuff in words. Okay, I saved time by going ahead and writing everything down. And the measure of angle ABD and measure of angle BDE equal 90 degrees. That was these angles right here. And we knew that because they told us that ABD and BDE were semicircles. So that's how we know, because those angles are inscribed in semicircles. That's how we know they're 90 degrees. Now then, just in case we're not positive about the other half of the circle being a semicircle, we can prove that angles AED and BAE are also 90 degrees because opposite angles of a parallelogram are congruent. And since all four angles equal 90 degrees, this is definitely a rectangle and could even be a square, but we can't swear to that. All right? Okay, let's move on. What you learned in this lesson is that Corollary 9.1 of the inscribed angle theorem states that an inscribed angle that intercepts a semicircle is a right angle. You learned also that Corollary 9.2 of the inscribed angle theorem says that two inscribed angles that are intercepting the same arc have the same measure. And we learned that the converse of that first corollary is also true, while the converse of the second corollary isn't necessarily true, because you can have two separate angles inscribed that are congruent that don't necessarily intercept the same arc. All right, when you get finished watching this lesson, please go and read lesson 407 in your LMS and complete the student guide, taking all good notes so that way you'll do good on your quiz and test since you get to use your notes for those. Also read through the lesson and the reference guide and add to your notes if needed. Complete 19 through 25 odd in your problem sets. And if you're still having some problems grasping these concepts, you need to contact me or attend Toga if you have any questions before you complete the 4.07 quiz. And as always, make note of any general questions you may have when you attend CC on Thursday. That's going to be it for this lesson. Well, no, it's not. Please, 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 please give me your course and section number with all communication. Now it's the end of lesson 407. Thanks for listening.